Hello everyone, welcome back to my channel. I have new class and students to land a job in the tech industry, and today I'm gonna help you guys with the two sum problem. Let's start for some minutes to read the problem first. This problem asks you to find the indices of the two numbers such that they add up to the target number, and this problem assumes that we have only exact one solution. So for example, if we have this array number, we will have the answer is 0 and 1, which is 2 and 7. They will add up to the target is 9 right here. So what we're gonna do now is that we always have the naive approach, which is that we use two loops, right? The first loop will look for the left target, and the second loop will look for the right target, which is we can use this one, which is very easy. First we will have the sign of the num, and then we will have the second loop from I plus 1, and then we will consider if these two numbers have the sum equal to the target, right? If they have the sum equal to the target, we will return them together, right? So this is the naive approach, and of course the time complexity would be really high, would be O n square, and the space complexity is constant because we don't do any additional array. So we will return minus, is it? No, we will not have the case when we don't have any solution, but just for the sake of a compiler, we put -1 and -1 here, right? So this is the naive approach, right? Two loops right here. Of course we can do it better by replace the second loop by using hash map. So how can we use it? So for whenever we look through a number, we will put it into our hash map. For example, if we have this, our hash map would be like this. Okay, if we look through 2, we will have the hash map of 2 equal 1, which means that the number 2 appear one time, and for 7 we will put the 7 into our hash map. And whenever before we put a number into the hash map, we will check if the number of targets minus with the current number already in the hash map or not. If we have this number in the hash map, would mean that we already have the number that pair with the current number in our hash map, which means that we can find this pair by using hash map. So how can we do it? First of all, we will look through all of the, let me comment this approach first. Yeah, we'll look through all of the elements in the array, and then we will put it into the hash map. Let me see if we should use the another map or something. Yeah, we can use another map right here. So in C++ we have map and another map. For map, the time complexity for each of the operation would be log n, because they implemented by red black tree. But for another map they use hash table to implement it, so the time complexity would be constant for each of the operation, for lookup, for insert, and for remove operation. Yeah. So I will call it the index of a number right here. So we will update the index of the number. Let me get the number first. The number would be nums I right here. And before we put it into the hash map, we will check if we already have the target. Oops, this one should be dot. The target minus with number right here. If we can find this one, which means that this should be different with the end pointer, so which means that we already have the pair, which is the index num of the target minus number right here. So instead of just put one as we did, we can put the index of each of the position. So for example, for 2 I put 2 0, and for 7 I put 7 1, and for 11 I will put 11 2 for the sake of outputting. Yeah, something like this. And when we return, because this problem asking us about the position, so we can return the index directly, right? So we can return the index and the current index right here, and the index of number should be equal to the current index, and we can return minus one right here for the sake of the compiler. Yeah, let's see how it goes. Yep. And of course the time complexity should be on, and the space complexity should be on as well, with n is the size of our array, of the nums array. Yep. And we also have the other approach. If we don't remember the syntax of the another map, we can use binary search to find if each of, for example, if we have 7 right here, we will search in this array to see if there is any 2 in the array. But first of all, we have to sort the array first. For example, for example 2, we don't have the sorted array. So what we're gonna do is we will store the pair of index and the value. Actually, we should store value and index. It would be easier for us to implement later. Yeah. So after we store the value in the index, we will sort the array, and after that we will do the same thing over here. We will look for the target minus with the current number we have. If we can find this number, which means that we can find the solution, right? And how can we sort the array? For example, if we have this case, right? We have this case, we will have 3 0 2 1 and 4 2, right? We map the value to the index. So which is up this one, I will use a pair to store it. Yeah. So and then we can sort the array using the built-in function. Yeah. So first of all, we will have a vector, a pair. I will call it the value index mapping, and we will look through all the element in the nums array. Let's comment this one first. Yeah. Oops. Right, and then we will create all of the pair, value index pair, pushback. This one is 0 element, pushback, then the nums I and I right here, and then we will sort all of the element increasingly by value. So we can't just use the built-in function to do it. That's why I use the value index instead of index value, because they will compare the first element in the pair first, and then if the first element equally, they will compare the second one. Yep, perfect. And now we can use binary search right here. Then we first of all we will have left equal 0 and right equal to num size n minus 1, and then we will have a loop while left less than right, and we will have sum equal to value. Actually, instead of using binary search, we also can use two pointer right here, but I will do it later. I think first of all I will use the binary search first. First we will use a loop through all of the elements, and then we can do the same. Right, we will search from 0 to I to see the second element. So if we compare with our first approach, it would be the same thing, but we will optimize the second loop right here. Yeah, so it if we want to implement the same thing, we can just use we can just find from I plus 1 to n. It would be easier. Yeah. Okay, so right here we have the 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 current number be equal to nums I, and now we want to look for the target. The new target would be equal to look for would be equal to target minus with the current number, right? And then we will use binary search right here. First of all, we will get the mid element would be equal to left plus right divided by 2, and then we will consider if the log target equal to the value index mid. This one should be value index I dot first, and this one is dot first as well. We will return the value index second. Should we return it in any order, or yeah, I think that's fine. We will return the value index I dot second and value index mid dot second right here. Else, if we cannot find anything, we will consider if our log target value and the mid value, if this one is less than, we can consider if the target value is less than the mid value, we will have mid right equal mid minus 1. Let me try it again to see how it goes. If we have 2, 3 right here and the mid position right here, if we have the log target less than mid, which means that we have the log target equal to 2, we will have right equal mid minus 1. Yeah, that seems to be right. And then we will have mid plus 1 right here. Yeah. And we also return minus 1 right here. Oops. Yeah, it seems to be correct. And for the time complexity, it would be O n log n. Oops. Because first of all, we need to sort the array first, and then we look through all of the element, and we look for a number with binary search, which means that this one is n log n as well. So in total, we have the time complexity is O n log n, and the space complexity should be O n. And we can also use two pointer for this one. Yeah, let me comment this one first, and we will also have two pointer approach right here. All right. For the two pointer approach, we will do the same thing. First of all, we will need to sort. We do the same thing right here. and then yeah, but instead of using binary search right here, we will use two pointer. Yes. Okay, for two pointer we will have left and right as well. And we will consider the sum of the two elements at the left and the right position. For example, if we have this array, we will consider the sum of this one and this one, right? Left right here and right here. We can see that the current sum is 17 and the target number is 9, which means that we should reduce right by 1, right? So that we can have the smaller sum. So what I'm gonna do right now is that I will get the sum of the left first and right first to see if we have the sum equal with the target. We can just return these two values, right? Oh, oops. And then if we have sum less than target, I mean greater than target, right, we will reduce right. And if we have the sum is less than target, which means that we should increase left so that we can have a bigger sum. And right here we can just return -1 right here. And this approach would be O n instead of n log n, but we also have to sort the array, so the time complexity will remain the same with our binary search approach, because the sorting operation dominate our two pointer approach. Let's see how it goes. Yeah, I think that seems to be right for me. Alright, thank you very much for your patience, and this is our two sum approaches. We have hash map, binary search, and two pointers in just one exercise, and which is very great for us. When I choose the problem to practice, usually I will choose a problem that can solve by multiple approach. This will happen the same in coding interview, in in a real technical interview, when you have to consider the trade-off between multiple approach. All right, see you later.